Plastic waste is one of the most pressing environmental crises facing the world today. The United Nations Environment Program, UNEP, has pointed out that while more than 400 million tons of plastic are produced annually, the recycling rate is barely over 10%. Finding alternatives is no longer a task that can be postponed, and bioplastics have emerged as one of the most practical solutions in this global trend. Definition and classification of bioplastics. Bioplastics, a term covering substitutes for conventional plastics, now come in two primary kinds. One category, bio-based plastics, uses renewable raw materials such as corn or sugarcane. The other category is biodegradable, including PLA, BioPET, and PHA, which are designed to break down through microbes or enzymes into harmless byproducts, such as water and carbon dioxide. Even if produced from bio-based materials, plastics may not easily decompose in nature, while some petroleum-derived versions can be made biodegradable with additives. This means the assumption that bio equals eco-friendly is incorrect. It is therefore necessary to assess and apply different materials according to their particular features and properties. Applications and case studies. Bioplastics are already being widely applied across industries. In the food and beverage sector, Coca-Cola launched its plant bottle using sugarcane-based materials, and Pepsi introduced a bio-PET bottle. The medical field is particularly noteworthy. Absorbable sutures, drug delivery systems, and implant materials that naturally dissolve in the body can reduce the burden of additional surgeries and improve patient safety. In agriculture, biodegradable plastics decompose in soil, reducing costs and labor while minimizing soil contamination. Advantages and development challenges. The advantages of bioplastics are clear. They reduce fossil fuel use, limit greenhouse emissions, and, when conditions allow, biodegrade to lessen waste loads. At the same time, the bioplastics business is cast as a growth engine, fueling investment in new technologies while generating employment in a rapidly expanding green sector. Yet the challenges are equally evident. Production costs are high 2 to 3 times more than conventional plastics, and decomposition in natural environments can be slow, meaning they may not always be as eco-friendly as expected. Thus, the development and use of bioplastics require not only more effective technologies, but also policy support, recycling systems, and an integrated approach.